Hi, welcome to Lesson 4 of CSEC Chemistry at Edu Solutions Institute. So today's lesson will be focusing on the atomic structure. Now, the atomic structure comes with how atoms are arranged. So hence, we have to know exactly what are atoms. We have touched on atoms in our previous lesson, but just to note, a simple definition is that an atom is the basic unit of matter. And what this means is that matter is anything that is inside objects, the small particles that made up objects. Now, atoms are those small particles. Now, they are in all objects, liquid, solids, or gases, right? But there are many different types of atoms. Now, when similar atoms group together, we call this an element, all right? And therefore, we have our periodic table where we have over 100 different elements. And what this means is that each individual element in that specific element, they are a group of similar atoms. Alright, but those atoms are different than if you look at a next element. So we take element hydrogen, those atoms that make up hydrogen are different from the atoms that make up, let's say, helium or carbon. Alright, now in atoms we have three small particles that make them up, and these are the protons, the neutrons, and the electrons. What makes them unique? What makes them similar? Now, the proton has a positive charge, right? The neutron, it's neutral, doesn't have any charge, and our electrons are negatively charged. The mass of proton and neutron are roughly the same. So we say they have a relative mass of 1. Now, for an electron, the electrons are way smaller than the protons and the neutrons. Hence, we say their mass is roughly 1 divided by 1836 or 1840 for some books, right? So it shows us that that fraction will give us a very small number. And what that means is we divide the mass of any one of these by 836 or 1840, and it gives us the mass of 1 electron. So it shows us it's a very small particle in comparison to the other two particles. Now, where are these particles formed? Now, in the atom, right, we have two parts. We have what we call the nucleus, which is in the center, right? And in the nucleus, we have two particles. These particles are the protons, which are going to represent it by P, and the neutrons, which are going to represent by the N. Now, around the nucleus, we have shells, right? And these shells now, those are where the electrons are located. So the electrons are on the shells. Alright, so what we're going to look at now is how do we represent the structure of atoms based on a specific element. But before we look at that, we should note that the elements in our periodic table have a specific structure in which we write their symbol or representation. Now, here we have an example which is the standard, where the symbol is placed right here, and this is the X represent the symbol of the element. All right, this Z here represents what we call the atomic number or the proton number, and based on this, it means how much protons this specific element has. The top number here, the A, would represent the mass number. And what the mass number is, it's basically the two particles that have the most mass, right? Which would be your proton and your neutron. So it's the total of protons and neutrons that's inside the nucleus that will give us the mass number. So, for example, if we look at hydrogen, hydrogen symbol is H, right? It has an atomic number of 1, if you look in the periodic table, and it also has a mass number of 1. Now, we notice that also we can call this atomic number the electron number for a neutral atom. So it also tells us how much electrons are in the atom. Right? So it tells us protons, which is the same amount of electrons. Right? So therefore that leaves us, how do we know how much neutrons are present? So to find how much neutrons, call it N, it would be the number of, it's their mass number, which is A, minus the proton number, which is Z. So therefore for hydrogen, hydrogen has a neutron number of 1 minus 1, which is 0. So hydrogen is the only element in the periodic table that does not have a neutron. Alright, so now we know how to identify how much protons, how much electrons, and how much neutrons. And we know the symbol. Let's do another one. If we look at lithium, so lithium is Li. Notice the first letter is capitalized, and the second letter is a common letter, which is primarily important. For a specific element, if it has 2 letters for the symbol, the first one is always capitalized, and the second one is common. So for lithium, this is 3 and 7. Alright, so therefore we know that lithium has a proton number of 3. It also, in its neutral state, has an electron number of 3, and its neutron number, which would be 7 minus 3, gives us it has 4 neutrons. Alright, so let's look at how do we represent this on a structure of an atom. Now, to note the structure of an atom, they have different amount of shells. Now, the importance of these shells is that it tells us how much electrons each shell holds. So the first shell can hold a maximum of 2. So before we go to the second shell, we have to ensure that at least 2 is present. And on our second shell, it holds a maximum of 8. Right? The third shell, primarily for elements above 20, holds 18, but for elements below 18, below 20, we're going to use 8. Right? And then we need fourth shell, which will hold a maximum of 32, but again, below 20, we're going to just use 8. So we only focus on the first 20 elements, so the order in which the maximum will be 2, 8, 8, 8. Right? So let's look at the structure of lithium. So the first thing we do is to draw our nucleus. At the center, we put in how much protons, which is 3, and how much neutrons, which is 4. And then we look at our electrons. So we note we need 3 electrons. So that means we need a first shell here. The first shell can hold a maximum of 2. So we're going to do, we know the 4 cardinal points. So we go north, south. So it only can hold 2, so we only need that shell to hold 2. But we need 3, so that means we need to do another shell. Right? So since we already accounted for 2, we just need 1. So therefore we go with just 1. Alright? So therefore if we count 1, 2, 3 electrons, 3 protons, and 4 neutrons. Alright? So that's how you know how to draw the structure of a specific element. Now let's look at another one, but let's going to look at a bigger element. So that element we're going to look at would be calcium, the last of the elements that we focus on at this level. So for calcium, it has a symbol of C, common A. It's 20 and 40. So again, we identify the proton will be 20, electrons would be 20, and the neutrons would be 40 minus 20, which is also 20. So the structure of this would be, again, we have our nucleus in the center, right? Protons 20, neutrons also 20. And then around we go with our shells. So the first shell here will hold a maximum of 2, right? But we need 20, so we need more shells. So the second shell can hold a maximum of 8. Do we need all 8? Yes, because we need 20. So it goes north, south, east, west. That's 4. We can hold more, so we go again north, south, east, west. Right? So now we have 10 elements here, electrons here, sorry. So we need another one here, which are going to hold 8 again. So we go north, south, east, west, north, south, east, west. So here we have 8, 8, that's 16, 17, 18. So that means we need one more shell. This one can hold 8 again, but we only need 2, so we go north, south. So here we have the structure of calcium having 20 electrons, 20 protons, and also 20 neutrons. Right? So the structure of any element can be drawn once you know the mass number as well as the atomic number. And it's important to know them for the first 20 elements. Right? So we'll be seeing a lot of these elements going on in chemistry from here on out. Now, the final thing to learn about the atomic structure at this level is to know about a term called isotopes. Now, isotopes are the same element, but they have different masses. So, isotope means they are the same atomic number, but their mass numbers vary. So, the basic isotope, or the first one, is hydrogen. Hydrogen exists as 3 types. So all of them have 1 atomic number, but the mass numbers vary 1, 2, 3. So this one is the one that we use primarily in the periodic table, but it also exists as hydrogen with 2 mass numbers and hydrogen with also 3 mass numbers. So we notice that they have the same atomic number, but different mass number. And if they have different mass numbers, that means they also will have different amount of neutrons inside their nucleus. Alright, so what do the purpose of isotopes? Because they have different masses, right? Some of these isotopes are used primarily in some different industries. So like in the medical industry, where we have radioactive isotopes that can be used to treat cancer patients in radiotherapy, right? Or it can be used to sterilize medical instruments, right? Or it can be used as tracers. Now, tracers are you allowing these substances to pass through so you can actually identify any problems that's happening. So like sodium 23 is a tracer that's used inside the body or in plants to flow through the systems to identify any blockage or any obstacle that's inside those systems. Right? Then we popularly one is carbon-14 dating, where scientists will analyze the amount of carbon-14 that's present in dead and decaying objects to actually predict how long they have been dead for. So that's some of the uses of isotopes. Now that's the end of today's class. Hope you have learned something new today, and I'll see you next week. Thank you for watching.